Similarity is what we call it when two solids are the same shape, but one is larger or smaller. And that happens when the ratio of corresponding sides is equal. So I'll show you what that means. This is a solid. It's a rectangular prism. This is a larger rectangular prism. And these two are similar. They're similar because they're the exact same shape, not just because they're rectangular prisms, but because one has been the stretched out version of the other in every dimension. And here's how you would prove that. So what I'll do is look at each set of corresponding sides. By corresponding, I mean they're the ones that go together. These two go together not just because they are the ones that are written at the bottom, but 5 is the longest of the 3 dimensions of this smaller prism, and 12.5 is the longest of the 3 dimensions of the larger prism. So if I look at the ratio of these, one divided by the other, that ratio is 2.5 over 1, or 2.5. It means that this measurement here is 2.5 times larger than this measurement. And that is called the ratio of similarity between these two prisms. If they are in fact truly similar, then all the other corresponding measurements, so the middle of the 3 dimensions and the middle of the 3 dimensions here, meaning 3 is between 5 and 2, it's the middle, and 7.5 is between 12.5 and 5 is the middle. The ratio of those two, 7.5 divided by 3, is also 2.5, same value. And these, the smallest of each of the 2 prisms, the ratio of those 2 measurements is also 2.5. It's the same. It's the same for all of them. And that is proof that these 2 prisms are similar. So what we would say is that the ratio of similarity between these two is 2.5, and that means that this is 2.5 times larger than the other in every one of its dimensions. How do you use that ratio? Well, if a problem tells you that 2 solids are similar, meaning that we know that they're the same shape, and that one is larger or smaller by the same factor in every dimension, it means that each measurement is going to be the same number of times larger or smaller. So because I have these 2 heights, I can figure out how much time or how many times larger this one is or how many times smaller this one is. So if I was to look for the missing measurement, the radius of this cylinder, I could figure out that ratio of similarity by looking at the 2 heights and know that this radius must be the same number of times smaller than this one. And another way to look at that is to set up a ratio where one is equal to the other and cross multiply. I know that the larger divided by the smaller in their heights has to also equal the larger divided by the smaller in the radius. So I've put both the larger ones on top to end up with bigger numbers on top. If you're looking for the ratio of similarity, that means that it won't turn out to be a decimal or fraction value. It should be a bigger number than 1. And if I fill in all the blanks there, all I have to do is cross multiply to figure out that missing value. And it turns out to be 1.25 meters. That's it.